Okay, for this next video, we're going to do a somewhat more complicated problem, and you'll see why when we graph it. First of all, we don't have the graph. We have the functions, and we're going to have to graph. So you're going to have to come to terms with all your old graphing techniques. So the first one we have is a polynomial. So let's get the vertex of that polynomial, and it's a parabola. I'm sorry, not a polynomial. Well, it is a polynomial, but I'm just jabbering on. Okay, so to remember how to find the vertex, the x value of the vertex is the opposite of b over 2a. So for this, it would be 5 over 2. So the vertex x value is 5 halves. To find the y value, we stick 5 halves in there. So that would be 25 fourths minus 50 halves. Nope, minus 25 halves, sorry. Which is going to be 50 fourths, minus 7. So that is negative 25 fourths minus 28 fourths. 7 is 28 fourths. So I have a negative 53 fourths, which is 13 and a fourth. Negative 13 and a fourth. So there's my vertex. So I've got a little graph down here, and let's plot that vertex. So let's see, 5 halves is 2.5. So, and then I'll go down 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are you bored yet? 10, 11, 12. Of course, I don't have 13. 14. So it's a little bit right there. Let's just call it right there, okay? For now. Of course. So I need a couple more points. So let's go and plot a couple more points on there. This isn't going to factor, so I'm not going to bother. This does not factor evenly, so the zeros wouldn't help us. They'd be weird zeros. So let's just plot points. It'll be easier. So let's see. X and Y. And we already have 5 halves and negative 13 and a fourth. And we also know when x is 0, y is negative 7. So we can get that one. 1, 2, 3, 4, 5, 6, 7. So there's a point right there. So I'm coming up here. And that would also mean it would be like a point about there. Okay. Okay, getting better. But I need to get past the x-axis. So let's try negative 1. That would be 1. Let's just do it here. 1 plus 5 minus 7. So that gives me 6 minus 7, which is negative 1. So negative 1, negative 1. So right here. And that means if I'm doing symmetry, that's 1, 2, 3 away. So 1, 2, 3 away about there. Not that dot. That's a weird dot. Okay, so I'm getting there. I'm just going to do that. Okay, so that's a good rough sketch. Hopefully it'll help us. I'm going to erase this stuff. Because I have limited space. Okay. The other graph was x minus 12. Well, that one's easy. So I'm going to do that one in blue. So x minus 12 would be starting at negative 12. So I think that's the very last line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. And then going up 1 over 1. So we're right here. This one, this one, this one, this one. So that's going to be that graph. Okay, we want the area between the curves, and, okay, I didn't tell you that, negative 2 to 5. So let's get the intersections. That's what you need. You need these intersections. This is going to be weird, though, you're going to see. So this intersection, how do you find the intersections? You put them equal to each other. X squared minus 5x minus 7 equals x minus 12. So you get x squared minus 6x plus 5 equals 0. So that's x minus 1 and x minus 5. 7 equals 0. So x equals 1 and x equals 5 gives you the intersection. So they're going to intersect at 1. Let's do purple or something. So they're intersecting at 1 and 5. And you kind of need to know that. So at 1 and at 5. 2, 3, 4, 5. So this must be 5. So if we put y into those points, this is 5, negative 7. And this is 1, negative 12. Now you can see, if you could do this with your calculator, you would just put this as F1, and this is F2, and find the dang intersection of these points, and you're golden. Okay, but you see the intersection was at negative 1, and I'm supposed to do it back from negative 2. That means I have to do this little piece. So the graph is like here. So there's a piece I'm coloring in purple right here. That's one piece. And then there's a piece I'm going to color in blue, which would be this piece. Now, the reason I'm coloring them different colors is there's your interval from negative 2 to 5 over here. And during that time, it switched where, remember, our integral is the top minus the bottom. But what happens if during the graphs, they switch from which one's on the top and which one's on the bottom? That means you have to split them up into two pieces. So if you're looking at which one's on the top from negative 2 to this intersection, so from negative 2 to 1, the parabola is on the top, and this straight line here is on the bottom. But then over here from 1 to 5, the straight line is on the top right here, and the parabola is on the bottom. So that's all. We just have to divide it up. So all this would be very easy to get these numbers with a calculator. It's just a little harder. But you do it we found the intersections. That's what we needed. So here we go. So from negative 2 to 1, the first intersection, on the top is the parabola. So that would be x squared minus 5x minus 7. And then you would subtract the bottom, which is from negative 2 to 1, x minus 12. And these are dx. Now that's the first piece, and then you have to add the second piece. And the second piece, you would have from 1 to 5 of x minus 12, and then minus 1 to 5 of x squared minus 5x minus 7. Now we can put these pieces, this piece together and this piece together. So let's do that. Negative 2 to 1 of x squared minus 6x plus 5 dx. And then it would be, that's this, and then this one would be plus 1 to 5 of negative x squared plus 6x minus 5 dx. Okay, so then you just have to do the integrals. So I'm going to stop and write down the integrals so it's not boring while I'm writing them out, and then you can check your work too. So you stop and try to do these integrals out and see what you get, and then come back and see if you got the same thing I did, okay?